building 9.
So you can see how this would help for maintenance ability. And you can actually, the hand that you have there, you can make it display
Unscrew a
as,
screw,
yeah,
that kind of thing.
impact
So they can say
driver.
they want to bolt a little bit differently and they can actually see how it gets moved.
You can set constraints so you can actually close and open doors.
It's like, it looks so real.
It's exact. So this.
Look at your hand over
What's so
there.
nice about the Techfit software is that what you design in CAD, similar to if you're sharing a WebEx or your screen, you just display it up here. There's no, it doesn't go through any pre-processing to allow it to, you know, to just put it here. And then if you,
How close to the screen?
yep, you can get real close, real close.
Oh.
Wow, that's cool.
And
I
then
feel
as
like
you,
I'm about to run into like the thing.
yeah, so this, I mean, so,
How close am I to this?
oh, you got a little more room. So if you walk over, so
Just
walk,
don't hit your head.
so walk over towards, walk this way. I see how you, so it's, it
Oops.
follows you. So it's, and if you, so bend over and like look, once you get closer to the displays, yeah, so it follows. So you can actually measure, you know, how much distance it is to reach for something.
Oh, right there, Christopher, look at that.
That's neat.
That's huge, isn't it?
Oh, almost fall back.
What part of the engine is that?
Turbo outlet right there.
Wow.
So you can see how detailed it gets and that
Yes.
engineers are really looking and figuring out the best design at the same time.
Wow.
They do speak a different language though, so.
Yeah. This must be the generator here.
You're in the radiator cap. So you're in the cooling system right now. There's the radiator fan.
Wow.
Below you should be
That
an
is so
air
cool.
compressor.
So it pressurizes the system?
The air, it forces the air through the radiator.
Oh.
Number 2 tab.
Now how much detail does it break down into?
It would have complete detail. This is actually the newest loco that we're designing right for the India
Okay.
build, so it's still being worked on.
Working, or again, it doesn't always have to be a prototype. It could be just to learn and experience the tools and,
Oh, okay.
and what they're doing. So
All
just
right.
basically getting a hands-on feel of what they're doing.
All right.
Your creativity gets sparked when you start having your hands do different things.
Yes, it's like when you do, like you said, when you go to college, a lot of people
Yeah.
look smart and actually get out there in the world and start working with things. It's
Yeah,
different.
a little different.
So those are our 3 main labs. It's for inspiring or whatever you have. But it's got, I mean, there's Wi-Fi throughout. Try to keep it fully stocked so they can do as much as we can. We've been having a little trouble with a model there. There's actually, this CNC machine is will actually, what you take a 3D print at the same model, will CNC route it. It keeps, that's a little complicated model and it keeps crashing on us, so.
Oh,
I'm thinking it's a dull bit, but we'll have to give it a try here in a second.
In normal, I should say years ago, when we were doing 5, 6, 7, 800 locomotives, there was always one available that was on trucks, and I'll show you later what I mean by the trucks. We do a lot of international locomotives now, and they go overseas, so we don't put the trucks under them, and we build them on what we call T-trucks, so you can't run them. You can't run them in the facility, or we don't take them up to the track test to run them that much. Now, we have one locomotive, luckily, right now that has trucks under it that we can move
And
and
also, are we
drive.
going to be riding on the same locomotives that we saw yesterday?
We are going to try to get you on one of these. I have a Rio Tinto. So Rio Tinto is a very interesting locomotive. Those go to Australia, and they have a mine in Australia, and they make lots of money mining, and they buy locomotives from us. And it's neat because it's the most powerful locomotive we have. When we do the track test, if we're running like a normal, years ago we'd run a lot of BNs, and if I was to run up a track with one BN and one Rio, the Rio would pull the BN so hard that you had to put 2 or 3 BNs to keep up to the pace of that Rio pulling it. It's that much more powerful locomotive. But we'll get you on a Rio.
And the reason why it needs to be so much more powerful is those locomotives actually go through some of the most remote areas in Australia from one end to the other. I think it's called the Pilbara area,
Yes.
and it's one of the hottest areas, and it's very arid. So you really have to build the locomotives based on what their actual conditions, their running conditions are going to be like. And that actually, I can send you a link to something that you can actually see it running. But it's like, we call it like the electric snake, or nothing like the snake, because it goes all the way around. So it's just really fascinating.
Another neat thing about the Rio, the customer comes up to inspect these things, and there's differences, and I'll show you better on the locomotive, but there's a fuel pipe. This is your fuel tank, and this pipe comes up, clear up to this walkway. On a normal locomotive, it's down here on the ground, and you fill up a locomotive just like you would a car. You have a little gas handle and you just stick it in there. Well, the reason it comes up to the walkway on a Rio is because they don't want to go on the ground because of all the snakes and other animals.
oh, nice, yeah,
Interesting.
that makes me feel real
Yes.
safe.
Me being curious, in my younger, I've been here 26 years, my younger years, I was like, what the heck do they do this for? When the
Yeah.
customer would come up to walk the locomotive, and I was asking these type of questions, and I was like, okay, that makes sense. They also have a lot more lights underneath their locomotive for that same reason, so they can see what's around them when if they have to stop. Or a powerful unit. When we run the test track, what you're trying to do for our test is you have one pulling at all times, and then you have one braking. And what you're trying to do with the one pulling is you want to go through all the different notches of the locomotive and pull while this is braking. And so you're fighting the two together. And then you just flip it around and go the other direction. This one will pull and this one tries to stop it. Well, when that Rio is pulling, it takes 2 BNs behind it to try to stop it from pulling, or it'll just go. So these pictures here are a lot of what we used to do. Now, we don't do a lot of these locomotives. They do them in our Texas plant, but Burlington Northern, you'll see all over the United States. The UP, you'll see everywhere. CSX is one of our favorite locomotives to do. We're very customer focused with them. The customer's here all the time. We work real well with the customer. Also a US locomotive, Norfolk Southern. The Canadians, we do a couple of Canadians, the CNs and the CP. What's kind of interesting about the Canadian locomotives is, so if you think about Canada and being in the wilderness up there also with a lot of snow, heavy snow, we put a lot of safety equipment on there. There's a microwave, a hot plate, a refrigerator. Their seats lean the whole way back, so if they get stuck in the middle of nowhere, they can actually sleep on these in the chair.
Oh.
Their seats are also air activated, where a normal seat just mounts to the floor. These ones are on like shock absorbers for a comfort ride.
Okay.
We give them a very big first aid kit. They have a stretcher, in case they're stuck in a snowstorm in the middle of nowhere.
Wow.
They get everything they need. And you get big differences. We're building for Canada where it's cold, and then we're building for Rio Tinto when it's it's hot
Hot
and
and
arid
humid,
down there. So
yeah.
you get a bunch of different things. We're doing Pakistan locomotives right now. We do for Angola. We're the international facility now. Usually not big numbers of locomotives, where back in the day, PN, we might do 300 in a year. When I'm doing a Rio right now, I'm only doing 3 of them. Angola is a nice run at like 79, but mostly for internationals, you might do 3 to 10 locomotives. So it's a different ballgame,
The
but
reason
it's
why we do a
interesting.
lot of that here as opposed to like the BNs, we've been making them for years and they know how to make them. Here you have people working here that have worked here for more than 40 years. The technology expertise that you have in this facility is amazing. So we even have people like in the tool crib or wherever who will come over, they're like, okay, something's not working here, and they'll develop something to be able to make things happen. So
Okay.
the expertise that you have here and all of the differences that he was talking about with international locomotives, all of that, having that expertise would bring.
Right.
But this is
Right.
bottom side assembly, so this is actually the locomotive upside down. It comes in from building 5 where they fab it, it comes in, they roll it upside down, and you're doing just assembly of mostly this pipe rack that they put in. There's a wireway, and then they do some assembly, and this is where your trucks would sit once it gets flipped back over. It'd be nice to see them roll it, because it's pretty impressive taking a giant piece of steel and turning it
Oh,
upside
yeah.
down. So this is upside down, this is station 1, the very front of the building. This picture here is of our engine area. Our engines are built in Grove City, which is about 45 minutes south of here. I honestly, our engines, it's the top of the line, it's the best thing our locomotive has going. It's very well built, it runs very, very well. That's one of our prides to this locomotive, is that engine.
And those engines are mostly designed here. You know, when I talked about the technology has different centers of excellence. The engine technology center of excellence is here.
So everything's, a lot of this is just, I mean, this is like General Motors, you got the tech center and you got all the plants, this is everything
All
kind of
together.
under one roof.
Yes. Wow. So then we move down the line and we'll go to station 3 next. Now station 3, they're flipped back over, so this is top side, there's your fuel tank here, they've already done all the piping and the wiring, and then they start putting on the individual cabs. This would be your main cab, an aux cab, this is where the electronics are, the bulk of the electronics. The main cab is built across the street in building 12 and brought over. This back here is the radiator cab. This is the cooling system, has large fans on the top, the water running through here, and there's a couple of blowers in here. That's also built in building 12, and this is where your engine would sit. So this is your engine cab, which is just a sheet metal box with doors on it that sits over top of the engine.
Okay.
It's neat, it's pieces, it's just like building blocks of a locomotive all coming together over here. This is we call final assembly, it's big assembly items. Now,
Well,
there
this
is
is
a-
where I'm saying you have sheet metal all the way to the final locomotive. So that cab is actually built over there, but it starts out as raw sheet.
Right.
So they actually physically pull it together from scratch.
A lot of weld, very weld intense operation. Welding all those cabs down, a lot of work, a lot of wiring work. We basically divide our guys up into crafts where we'll have our welders specializing in welding, our wire guys, our pipe fitters, a lot of piping, the engine oil, water, piping. And then your general assemblers that are doing all the little assembly stuff, putting the cabs down. And there's a lot of little pieces you're putting on as you go. So that's actually topside assembly, or what we call station 3. Station 4, so you're going to pick this thing up out of station 3 with the crane, and you move it down.
How we doing, Dan? Yep.
You find that your trucks are lined up, you pick it up out of station 3, you bring it down, and then you just set it on top of these trucks.
Wow.
Each locomotive has 2 trucks,
Wow.
typically 6 wheels to a truck. We do have 8-wheel, and we also have trucks we call a steerable truck, which is and 2 different types of a steerable. All it does is it lets your wheels move different ways on the track. If you ever had a chance, what's the horseshoe called down in Pennsylvania, the curve?
Horseshoe curve.
We're going there today.
All right. The neat thing is, you stand in the middle of that thing and you watch that, and the noise from the wheels pushing against the curve is what you really take away from that. It's
Now, how many, what do you produce, like 1 a day, or?
Now, we're doing, this year we'll only do 143 locomotives, so it's a little less than 1 a day. we're manned right now to do 143. The unfortunate part of this business is we ride with the economy.
Right.
And we actually take a little, once the economy comes back, it takes a little bit more for us to come back. So we're kind of a low point right now. Like I said, I've been here 26 years and it's just been like this the whole time. So our manpower fluctuates, and the number of locomotives fluctuate. We can get a locomotive through here rather quickly. Different customers, depending on what they want, you know, we might adjust our schedule to get something done a little faster. But we kind of, we're paced right now. We're 143, a little less than one a day. So, but we've done, like I said, we did the top number, I think, was 910, 920. You know, I like it, but that does get taxing, and it was a great year. I mean, we put out a lot of locomotives, but it's, you know, everybody's doing it. The union are doing it, the management team's doing it. It's just non-stop. You're just going like crazy. So now that we have the Texas facility, then the Texas facility is basically doing all the domestic locomotives, US locomotives, and we're doing all the international locomotives. So we have the flexibility to go between the 2 points.
Just curious, why did you guys get stuck with the international and they're doing more domestic? Because you guys have the engineering capabilities?
There's a setup
or?
very different. Again, remember that this is over 100 years old, the plant is. If we were to design it today, you would make it design more, even if it's not a moving manufacturing line, you would want to make it have it set up that way.
Okay.
This obviously was done, you know, over 100 years ago, before lean was invented, and there's been so many changes in locomotives. So how you would design it would be different. So how they were able to design the plant from scratch down in Texas.
Okay.
So they were able to design that to be able to be really efficient, to go all the way in and all the way out.
We can do oddballs really well.
The technology,
we fix
yeah.
problems
Yeah.
really well. And when you get into an international locomotive, just because they're so different,
The
and you may only be
expertise.
doing 3 or 5 or whatever, it's easier for us with the expertise that we have to piece one together, where it's easier for them to go in a set flow and just mass produce.
Oh, all right. Go ahead.
Then I may take yours instead of
Videotape
getting
it.
mine, so I don't get.
All gonna stay on the ground?
Yeah, I'm staying here.
Okay, this side might be a good spot. You can get some good footage over here. All right, come on in.
I'm gonna grab.
No GoPro.
You got your camera though.
Yeah, this one goes to Australia. Yeah. So you want a motor?
Yep.
Okay. So this is our engine control switch. We'll go to run. Okay.
Start.
Nope, that's already running. And then come on over here. Flip a couple more switches. Reset our brakes. We'll build air pressure here. This is like the controller of everything. It's all electronic now. All your information is displayed on here. Okay. This is our brakes for this unit. Okay. There's your bell. You want to turn your bell on. Flip that switch down once. There you go. Okay, that's on. This is our forward. Release our brakes.
Where's the horn?
Horn's right here. I'll let you run that. We're building effort right here. Our power. Okay. 1 sec. It has to do some calculating. That's the emergency. Do this little sand signal here.
And the red light.
And the red light comes on. So right now, sand would be going on our front wheels to stop. Okay. Let that run out. That takes 50 seconds. goes to Australia where it's so bright. And these are their extra shades to block the sun out. Yeah, so you guys can see better. It doesn't get so hot in here. There's curtains that hang here when it's finished. Close the curtain.
Does this one come with like a microwave and all that kind of stuff?
Yeah, your microwave goes there and a tea kettle so they can make coffee or tea or noodles or whatever. You want to run it now?
Sure.
I'll have them plug their ears because it's very loud. Go ahead and press it right there. Yeah. See a little horn
I
on it?
actually like that.
It's a
horn.
great horn. It really is. There's your bell, direction. Notch 1, forward.
I think it's, oh, there you go.
There we go. It takes a little bit to get the electricity going. Always do a brake check, make sure our brakes work. So this is just notch 1. There's 8 notches, 8 power notches. So you can really get going.
How fast will it go?
This is governed at 70, but they will go faster.
Just like the speedometer on your car?
It's just like an auto, yeah. Sure, yeah. One sec, we'll stop here. Go ahead. So your icon comes up here. And when you do that, your ditch lights now are flashing. See that? Yeah.
I see.
So it seems like you're going through a crossing. Slow speed, target speed. You can set your target speed. Say you want 3 miles an hour. You can go with 4. Okay. No matter what we notch it, that sets our speed at 4.2.
So there's no way you can speed.
That's right.
So when a cop tries to pull you over,
Right. There's all kinds of different things that you can do. They'll use that, say they have a big long train going under a conveyor, and they can set their speed. Instead of searching for a speed, they'll set the slow speed, and he can just fill the conveyor, can fill all the cars at a certain speed, and they'll set the conveyor at that speed to fill them evenly. Yeah, this actually hauls ore, iron ore, and copper, and different things like that, different minerals. Ooh, that was a good one. So safety, we will shut our power generator off, set our brakes, isolate, and you can sit here and we'll open these windows. There you go. How's that?
great.
Well, you can check out these here. These are your engine controls, your gauge lights. These will turn on and off. These are your headlights right here. this has a auto stop, so 3 minutes. See that on the screen, the icon? It'll shut off in 3 minutes. So this here, press that once. That one. Go ahead. Press it once. And that gives you 2 hours that it will idle and run. And then after 2 hours, if it's all warm, it will shut off to save fuel. And then if it needs to be heated up, it'll start up on its own. Yeah. All right.
Thank you so much.
You're welcome.
Thank you very much.
Anytime. Yeah, thank you. Yeah. Don't forget to check out the restroom down there. It's brand new. Never been used.
Restroom?
Yeah, right here. This guy has a refrigerator, restroom. Yeah. Yeah, right there. Open that door. Slide the handle to your right. Right there.
There's the bathroom.
Oh, that's the bathroom. And then there is a sink.
Yep. Thank you
Okay.
again.
You're welcome.
Thanks.
Yep, thank you.
So my best analogy for this is think about your teachers in school, right? Okay? Your teachers have 25 students, and when you guys all do a test and you give them, she goes through and looks at all the answers and says what's good and bad, right? Okay? Well, I have guys that look at every locomotive and say what's good or bad. Okay? So I basically have a bunch of teachers here that are the best teachers in the world and figure out how to control the students. Okay, so this building's full of teachers, if you will, but locomotive experts. Okay, so you want to go meet the guys?
So, and the locomotives are students.
Exactly. That's my analogy. So it'll be interesting because like one teacher has 25 students, right? Okay, so how many locomotives do you think my guys are watching right now, today?
Probably all of them.
All of them, which is about 17,000. Okay? So 17,000 locomotives around the globe. We'll go show you a map. They're running all around the world. And I got a bunch of teachers watching all 17,000. So how many teachers do you think we're going to have? If one teacher takes care of 25, you do the math, that's about 700. Okay? I don't have 700 teachers, but we'll see how many there are when we go around. Does that sound okay?
Okay.
Okay? So the first thing I'll show you is how do we do this? It's not heavy. That's how we make things for locomotives. They have to be big and heavy.
Trying to work out.
Let me get a picture of you with that.
So this
One more
is,
time.
that's the brains on the locomotive. That's the computer. Got it? Okay, so we put these computers on the locomotives, okay? And then they're connected to all the other sensors on the locomotive. Okay? Like this is a sensor. What do you think this sensor is for?
Maybe for like the fuel or.
Very close. This is for
That's what
oil.
I was gonna say.
So this one's for the oil. So this sits inside the oil. You know what oil does, right?
Oh yeah.
Oil lubricates it, makes sure everything, nothing. So we have to make sure that the oil is filled. So we put this in the oil tank and it tells us how much oil there is. It also tells us if it's shaking and if there's temperature. So there's a bunch of these. How many sensors on a locomotive do you think? How many of these do you think are spread out the whole locomotive?
Probably about maybe 20 or something.
Add another 0. There's about 200.
Wow.
Okay, so there's about 200, 300 sensors all through the locomotive, and they all talk to this brain. And then this brain sends them all to my guys, and these are like the antennas. So these are like our cell phone, the antenna's buried inside of it. But for a locomotive, we have to put it on the roof. So this goes on the roof of a locomotive. Okay, and we talk across cell phones, we talk about Wi-Fi, we talk about GPS, global position. Have you ever heard of GPS?
Yeah.
That's how our phones work. So we put all this on top of a locomotive, plus these sensors, and talk to the brain, and it all sends the data to this building. Where so I think if I do the math, 2.5 million messages a day, ends up being like several hundred messages come in every minute.
Wow.
Okay? So then they all come to my guys' computers. So remember, we're going to see how many teachers, 700 teachers, watching all these? We'll go meet the experts, okay? Go ahead in.
Thank you. Wow, this is cool.
Okay, Christopher, so this is the network center. So this is where we're watching all 17,000 locomotives. Okay, and you can see we got 2 guys at the desks. So those are my 2 teachers, plus Adam in the front. But then you see on the far right board, okay, that's Fort Worth, Texas. Okay, so this room, see the camera up here?
Yeah.
Okay, that room is connected to Fort Worth, Texas, where Andres is working. Andres is in the blue shirt. And if you look,
You can wave to him if you want.
see the little picture on the bottom there? That's Brazil. So there's 4 of these centers around the globe. There's one here, one in Fort Worth, one in Brazil, and one in Kazakhstan, which is over by Russia. So the 4 centers, so basically we have about 4 or 5 guys that are watching, they're our teachers, 4 or 5 guys watching all 17,000 locomotives. Pretty cool? So why would we watch them? What do you think we do with it?
You make sure that there are not any problems with the locomotives.
Exactly. So some simple things like let's say a locomotive's hauling empty coal trains. So there's no coal, it's just going to the mine. The trains aren't working very hard, but we can see if they're sick. Okay, so before they get loaded with coal, we send someone out to fix them. So like if you're on your way back to Michigan and you were about to stop and get fuel and we saw something was wrong with your car, we'd have them fix them while you're getting fuel. So that's how we do it. Okay? The other cool things though, like sometimes, sometimes people, like a train will stop and in like other countries, people will run out and steal the fuel. Because there's a big, huge diesel tank underneath it. Well, we see the fuel start to drop really, really quick and we call the cops and the cops go arrest the people for stealing fuel. So that's kind of some of the cool stuff these guys do here, okay? Okay, so let's take a look at the board here. We'll take a look at some of the stuff, and then I'll have you go sit with Greg. Greg's an expert. He'll tell you all the good stuff. Before we do that, these are like all the different parts of the locomotive that we're watching. If you look around the locomotive, like if you look out the front of a locomotive, there's a camera. Do you know almost all locomotives now have cameras that point out the front
Yep.
and record everything going down?
So that test track over there?
So that's the test track, and there's things like we identify where the milepost markers are so that we know where the train is, plus the GPS, and things that we'll look for are things like, you know what that's called?
Railway buckle?
Yep, that's exactly, it's called a sun buckle or sun kink. So when the sun gets so hot, like the temperature gets over 100 degrees, sometimes you get buckles in the tracks. Well, our cameras detect that, okay, and that lets the locomotive slow down and tells the guys to go fix the track. So that's one of the things we do with the cameras. And then here's that sensor that we looked at. It's looking at the oil levels, okay? So that sensor goes inside. And if we get a bunch of data that shows the same number, so this is saying, what's it saying, 100 gallons. So if there was always 100 gallons, that means that locomotive's okay. If you see the locomotive slowly starting to leak oil, means it has a small leak. Better get someone out to fix it in the next week. If we see the oil drop down all of a sudden really low, okay, then we know that thing's got a big leak. Maybe it hit a big stone or maybe something went wrong. You better shut that locomotive off or else you're going to lock an axle. So that's how we look at the different data signatures to figure out if the locomotive's healthy or not. Is that kind of neat?
You bet.
Okay. I'll show you one more example and then I'll let you talk to Greg. So there's the diesel engine, okay? So you know how the diesel engine works. First you put fuel in. Put fuel in, build compression, it fires and exhausts the gas. That's how the cylinders go up and down and work, okay? Well, we watch that work, and what we do is we watch every time a cylinder fires, we watch as it goes up and down, we see how much torque's coming out of the alternator, okay? Does anything look funny on that chart, on the bottom one?
Yep, that one.
That one didn't go up as high, huh? So that means that cylinder's weak. So there's something wrong with that cylinder. So that means the other ones are doing all the work, but we better fix that one pretty quick, or else it's gonna end up not being able to make horsepower, and then the locomotive's not gonna be able to pull the train, and then coal won't make it, or the
I see
train.
what you mean.
You understand what I mean? So that's what we do. We watch all this data with those computers I showed you, and we help the railroads go. Pretty cool?
You know about the railroads, actually, a lot other than just the trains, you're keeping track of the train tracks and
Yep.
stuff like that too.
It's exactly the point to the center. We've been around for 20 years, and it's worked out really, really good. And every year we get better, we look at different things. Here's a neat thing we actually do. We actually put sensors underneath the locomotive that inject currents into the rail so that we can tell if a rail's broken or not. So as the train's going down the track, it's sensing the ground. It's like having shoes that sense the ground. Wouldn't that be pretty cool if your shoes would tell you if the ground's loose underneath you? Well, that's what the locomotive's doing when it's going down, sensing for the track.
I see.
That is really neat though, yeah, because they don't have to have the track workers constantly out there. The trains are basically keeping track of the tracks.
Yep, and it's amazing because a train can go over a broken track a couple of times, but it can't go over it too many times because then you end up with a derailment, which is real bad for everybody.
Yeah.
Okay, so that's the high level view of this stuff. We'll go meet the guys that do it. Okay, come on, I'll introduce you to Greg.